Yeah, these are the standards for dimensioning mechanical components. And CY 14.5, dimensioning and tolerancing. That's the one we're going to be discussing in this class. But there's also a Y 14.8, which is about castings, forgings, and molded parts. And then there's a few others here that are listed. But and they've been evolving. Okay, like for example, ANSI Y 14.46. That's product definition for additive manufacturing. So we have new processes for manufacturing parts. So therefore, we would have new standards for dimensioning parts that were manufactured with those processes. Um, Standard-based tolerancing. So GD&T provides a means to specify complete control of product variation. Okay, so it supports application of solid models. So you can apply this right to solid models, or you can apply it to the orthographic projection views. That's like creating drawings, like we've done before in orthographic projection. Sometimes called position tolerancing, but it's really not positioning. We can control form and orientation and positioning and run out and also profile, which are all very different. So we have a lot of tools for completely defining parts. So GD&T is a general term used for tolerances applied to part features. It's a language, essentially, if you will, for communicating drawing requirements. Um, the evolution of this ANSI ASME Y14 standard kind of goes like this. It was ANSI back then, and now it turned to ASME in 1994. But these were all the evolutions of it, and we like to talk about 1994 specifically because it was kind of revolutionary what was done there with the geometric dimensioning and tolerancing. And since then, it's kind of evolved. There was a 2009 standard, but now your book is also talking about the 2018 standard. And they go back and talk about some of the changes in GD&T over those times. But for the most part, after 1994, any of those changes are just evolutionary versus revolutionary. I mean, it's not big changes. It's just clarifications and stuff like that. So why do we need new standards? To keep current with the industry, obviously, new methods of dimensioning and tolerancing and manufacturing require, new established dimensioning and tolerancing methods. Um, Add new and expand existing capabilities, meet emerging industry needs, clarifying, yeah, this is a big one, clarifying current methods. Yeah, so a lot of it is clarification. And then some other methods that we've used in the past, there's other ways to do things. Like, we've got rid of the concentricity in GD&T 2018, and we got rid of symmetry, because those were things that we could do with positional tolerances, so we don't use those anymore. Um, Current standard. Most figures show metric dimensions in the textbook. Most use recent issue of each applicable standard. So there's a lot of pictures in your textbook that show a lot of different things. And what you're looking at here is just a cartoon of one of the examples that you would find in your textbook, a typical example. Um, Application of computer-aided design in product documentation. Yeah, we transition from manual 2D multi-view drawings to 3D CAD models. Dimensions can be displayed directly on the models or obtained by a query of the model feature. Yeah, so in a lot of cases, this textbook talks about applying dimensions directly to the models, which is valid. Um, we mostly talk about applying dimensions to drawings. Because that's kind of like what we're doing. Because this is not a CADS class. This is a GD&T class. So, we're not going to be creating models just so we can annotate them in the models. But we will be talking about how that's done. And then product definition should invoke ASME 14.5. And that's really just for you got to say so on the drawing. If you're using ANSI 14.5, you got to come out and say so on the drawing. There should be a note that does that. In the next movie, I'll have an example for you. Um, Design through teamwork. Okay, this is objective 3. So producibility is the ability to produce product at the lowest cost and desired quality. Um, products that aren't producible have tolerances that can't be met, large scrap rates, So yeah, you can make some parts, but let's say if you scrap 5 parts, to make three, then you're not really making any money. So you really need to work on your producibility, and the best way to do that is through teamwork. You get advice from experts in each field, and you get collaboration and improvements in incorporating drawing changes before the product definition is completed. So in some cases, the drawing definition product will take a long time, just because everybody's got to, look at everything, consider all the tolerances, calculate all of the tolerances, and then come up with the best ways to dimension those features, if you will, to make sure that they're going to function properly in your assemblies. And we do that through collaboration, because collaboration reduces the need for changes after the design is released and production is started. Because there's always going to be changes once you start getting into manufacturing, things that you didn't foresee when you were designing the parts. And of course, it's increased efficiency. I mean, it might cost you time up front, but it'll save you in the long run. Now let's talk about the professions and trades that are affected by dimensions. Obviously, drafting. These are the guys who put the dimensions on the drawings and create the 2D drawings, and they also create the 3D models as well. Designers and design engineers. The designers and design engineers, um, they're the ones that are creating, the theory behind how all the parts work and how everything fits together, and the designers and the drafters take those things and commit them to um, the solid models and to the orthographic drawings. Dimensional management engineers. We don't have those where I work, but there's some people that look at the tolerances. And then there's manufacturing engineers and machine planners, like how are we going to make this part? So a manufacturing engineer is going to look at the tolerances on the drawing and say, well, geez, I think those tolerances are too tight for us to manufacture and using our particular machining processes. So the manufacturing engineers are going to have major inputs on the drawings. And finally, the machinists and machine programmers, like the guys who program the CNC machines and also the guys who run the machines. They need to be able to look at things and do the dimensions. Okay. Finally, it's the inspectors, the people who actually use measuring instruments to check the parts. Those guys have to know what these drawings say. Um, and then inspection planners, the people who plan how the inspection's actually done. Finally, it's the tool designers. The tool designers need to know dimensions, because they're the guys that are going to take the drawings of the parts or the solid models and design like the work holding fixtures or any assembly tooling or anything that they need. And then finally, your tool makers. So this is a whole list of people all the way up and down the organization that's involved in making mechanical parts that has to be proficient in dimensions and tolerancing. Um, so what kind of skills do you need? I think the skills show up here in Objective 5. Standard symbols define requirements and remove ambiguity. We like to use the standard symbols. I mean, in the past we've used abbreviations. We want to stay away from a lot of the abbreviations if we have good symbols nowadays, because the symbols are clearer. And again, this comes back to drafting standards and what your standard symbols are. Um, Improper application of dimensions and tolerancings is usually the responsibility of the design engineer, the designer, or the drafter. These are the guys that are committing these drawings to, either to paper or to the making electronic drawings and through the 3D CAD models and stuff like that. So those are the people that are most responsible for the design engineer, the designer, and the drafter. And we try to avoid non-standard symbols since they don't have any defined meaning, because really that's what we're trying to do, is create unambiguous drawings. Okay, so if we're using non-standard symbols or anything that makes it less clear, then what we're doing is opening ourselves up for some problems. down the road. And just to keep this movie short, I am going to stop it here so I can start up on the next one.